Good morning, children. Now we are going to discuss about static friction. Static friction. The definition of static friction is the frictional force acting between surfaces at rest with respect to each other. Is known as static frictional force. The frictional force acting between two surfaces at rest with respect to each other is called static frictional force. Here in this situation, static frictional force is directly proportional to normal force. Means like here, this is an object is at rest. Object of mass m. Then normal force is acting upward direction. Weight is acting downward direction. See here, the force of friction is directly proportional to the normal force. See, this is the static frictional force. Means when two bodies are at rest, one with respect to another, the force of friction acting between two bodies is known as static friction. Static frictional force is directly proportional to normal force. Therefore, the static frictional force is directly proportional to mg. Means like here in this situation, n is equals to mg. Therefore, Fs is equals to mu s into mg. Here mu s means coefficient of static friction. Mu s is equals to coefficient of static friction. Mu s is coefficient of static friction. Here the force of static friction is less than or equals to mu s into n. The coefficient of static friction, the force of friction is less than or equals to mu s into n. Means like here, force of friction is limiting force of friction is equals to mu s into mg. Limiting means when the block is ready to move. When the block is ready to move is limiting static frictional force. The formula for limiting static frictional force is mu s mg. The formula for limiting static frictional force is means like here, Fs limiting is equals to mu s mg. Otherwise, Fs is less than or equals to mu s mg. Means up to the body ready to move, but Fs is less than mu s mg. Once the body is just ready to move, the force of limiting is equals to mu s mg. This is force of friction. So here this normal force is always not equals to mg. Here the object is placed on the surface of horizontal we are placing. Then normal force is equals to mg. Suppose the object is placed on inclined plane of inclination theta. Here object is at rest. Means our object is ready to move. In this situation, what about the normal force? Normal force is equals to mg cos theta. Normal force is equals to mg cos theta. Fs limiting means here the body is ready to move. Means like here mu s mg cos theta. Are you clear enough for here? So normal force is always not equals to weight. Normal force depends upon the surface of the plane. Suppose here surface of the plane is horizontal, normal force is balanced to the weight. But in this case, normal force is always perpendicular to the surface. in contact of the surface, this is the normal force. But weight of the object is always acting vertically downwards, whatever the surface. Whatever the surface, weight of the object is acting downward direction. Because of gravity will act vertically downward direction. So normal force is not like that. Normal force will depends on the surface. Normal force will depends on the surface. Suppose let me consider a vertical surface. Vertical surface. Object is placed like this. So here this is the normal force. Then this one is applied force. F applied. F applied means rubbing of blackboard with duster. I applied force is like this. Normal force will be like this. Means in these situation, normal force is equals to F applied. Normal force is equals to F applied. So here force of limiting is equals to mu s into F applied. Mu s into F applied. So this is the one situation. This is the one situation. But keep in your mind always, the force of static friction is directly proportional to the normal force, not weight. The force of friction is directly proportional to the normal force. And the next one is kinetic friction. Kinetic friction. Kinetic friction means the force, the frictional force acting between the surfaces in relative motion. Kinetic friction, what is the definition of kinetic friction is? The force of friction acting between the surfaces of relative motion. Surfaces in relative motion. Surfaces in relative motion is called kinetic friction. Here, this kinetic friction Fk, kinetic friction is denoted by the letter is Fk. Fk is directly proportional to normal, then Fk is equals to mu k into mg. Here mu k is nothing but coefficient of kinetic friction. Coefficient of kinetic friction. Mu k is coefficient of kinetic friction. Fk is equals to mu k mg. Like here also similar conditions only. Normal force depends on surfaces. So like these surfaces only here also we should apply. Fk is equals to mu k into m. Fs is equals to mu s into m. So already I told the direction of frictional force is tangent to the relative motion between two objects. Tangent to the relative motion between two objects, or tangent then the two bodies are kept in contact. Means here frictional force. These are the two bodies are kept in contact. Either the frictional force is upward direction or downward direction. Depends on the block is moving. Which direction the block is moves? But frictional force is opposite to the direction of motion of block. The frictional force will act opposite to the direction of motion of block. So here mu k is coefficient of kinetic friction. Then this Fk is less than Fs. Fr is less than Fk. Means force of rolling friction is less than force of kinetic friction is less than force of static friction. Force of static friction. Or otherwise Fs is greater than Fk is greater than Fr. Similarly, mu s is greater than mu k is greater than mu r. Means coefficient of static friction is greater than coefficient of kinetic friction is greater than coefficient of rolling friction. Coefficient of static friction is greater than kinetic. Kinetic is greater than the rolling frictions. Rolling friction. Here, one more important point. The force of friction is always tangent between the two surfaces are in contact. And next one is the force of friction is independent of area of contact. The force of friction is independent of area of contact of bodies. Under area of contact of bodies, as long as the normal force remains the same. As long as normal force remains same. This is very important point. The force of limiting or static. The force of friction means like this is limiting or static. The force of limiting or static friction is independent of area of the contact. Of bodies, as long as the normal force remains the same. If normal force changes, the force of friction will depend on area of contact. And the next one is the kinetic friction is independent of velocity. Next point is kinetic friction is independent of velocity provided the velocity is neither too large or too small. Means like here, when an object is in the motion, in that object the velocity of the object is increase or decrease, there is no change in kinetic frictional force. The kinetic friction is independent of velocity of the body. Kinetic friction is independent of velocity of the body, provided the velocity is neither too large or too small. When the block is moved, suppose kinetic friction means the block is already in motion. In that motion of the object, velocity is increases or decreases, or when we are giving too large velocity or too small velocity, there is no change in kinetic frictional force. Fk remains same. There is no change.